With these types of questions, your question on the test will be something like, here's this equation, is it even, odd, or neither, and you have to decide which one it is. There's lots of different versions, so you need to be able to recognize an even function, an odd function, and a neither function. So when you have that type of function, the easiest thing to do would be to graph it. So I think this absolute value of x to the 5th power is, no, actually I think it's right here. Yep, it's right there. So the easiest thing to do is graph it. And so this is what the graph looks like. And this equation, or this graph, so this equation is going to be an even function because it reflects across the y-axis. Okay, this next equation, f of x equals e raised to the x minus 5, I think is right here underneath this monster. Okay, that's what the graph looks like. This is neither even nor odd. Okay. And then let's see, the third root of x I think is right here. Let me see if I'm right. Nope, that one's the fraction. So 16 is right here. And this one is an odd function because if you stick a pin right there, in fact I'll show you by rotating it, if I turn the graph upside down, it's the exact same picture. It's really cool. So this is an odd function because I can rotate it 360 degrees and get the exact same picture that I originally started with. Okay, so that's this equation, and then I guess this one is probably the cube root of 3. That one I believe is also an odd function, yeah. So I can take this equation, in fact let me copy this and paste it. Let me see. So here's this graph, and if I turn it 360 degrees, I'm trying to get exactly 360 degrees. That's kind of hard to do. There we go. Then I have exactly the same picture. Okay? So odd functions rotate around the origin only 180 degrees. Did I say 360 degrees? Sorry. 180 degrees rotation, and if you have the same picture, then it's an odd function. Now, guys, there's lots of different versions. Don't just look for a fraction and say, okay, that's automatically going to be odd, or don't just look for absolute value and say it's automatically going to be even. I want you to plug these into the calculator, look at the graph, and then decide if it's odd or even. Okay, the reason why is because there's some times where you have fractions and instead of being odd like it's normally is, it would be an even function like this equation here. And then also one thing I wanted to point out, and I've noticed in the textbook they don't show very many examples of odd functions that don't intersect at the origin. Notice this one intersects at the origin, so does this one. But this graph does not intersect the origin, but it's still odd because I can turn it 180 degrees. Let's see, let me try to get it to 180. Yeah, I can turn it 180 and it's still the same picture. Okay, so just because it doesn't intersect the x-axis doesn't mean it's automatically not an odd function. All right, so those are some examples of your graphs. Make sure you understand what odd functions look like, what even functions look like, and what neither functions look like. All right, next problem. Use the given information to write the equation of g of x and then graph g of x. Okay, don't worry about graphing g of x. On the test, there's going to be a list of transformations and you have to figure out the equation. So for 18, you have the graph of g of x is a translation of 2 units to the right of the graph of f of x equals e raised to the x power followed by a reflection over the x-axis. All right, so this, I don't know, werewolf is hiding the answer to that one. So my equation starts off e raised to the x power. To get it to move to the right, I'm going to do a -2 up here, because remember all your horizontal stuff does the opposite. And then we're reflecting over the x-axis, so the negative is right here. Okay. Now another example of one that you might see is a vertical stretch of this equation by a factor of 2, followed by a translation of 4 units down. And I believe this monster is hiding the answer. So notice the 2 is out here, and then the parent function or the original equation is all in parentheses, and then it's minus 4 because we're moving 4 units down. Now, what if this was your question, but this was not one of the answer choices? How might you also see this? Well, you might also see it if you distribute that 2, then it would be 2x squared plus, what, 8x? And then minus 4. That's another, those are equivalent equations, okay? Just make sure you recognize both. Let's look at this one. This one is mostly with graphs. They want you to graph each piecewise defined function, determine and analyze any key features such as domain, range, relative extrema, and zeros. I think on the test you'll be given a piecewise function like this one or something similar, and you just need to know what the graph looks like. Okay, be very, very careful with your inequalities. Okay, remember to find the inequality. Well, first of all, this is what the first graph would look like. And let me pull up the calculator. Most of you know where the inequalities are. In case you don't, well, let me just show you where to find the piecewise functions. So remember, you can use this option or this option. If you only have 2 different equations, you can use this option. If you have anything other than 2, you would use that one. And then for this example, we had 3 piecewise functions, and so it's like that. In this box, you put the formula. In this box, you put the inequalities. And remember, for the inequalities, let's say one was x had to be less than or equal to 3. So to pull up the inequalities, you do the control equals button here, and it pops at this window. And you can just click on the one you want and then do 3. Okay. To get from one box to the other, you just keep pushing tab. Okay. And notice that because I didn't have all this filled out, it gave me a syntax error. All right, so that's how you graph those. Make sure you can plug it in, make sure you know what the graphs look like. Pay close attention on your test. The answer choices are very similar to each other, so pay really close attention on what the inequalities are. Make sure you set it up in the calculator correctly and all that fun stuff, okay? So let's see, any key features, analyze any key features such as domain, range, and relative extreme and zeros. You're really not going to have a whole lot of test questions where you need the domain and range. Essentially, the domain for this is from negative infinity to positive infinity. Even though there's breaks here, because we have equal signs, it's going to be from negative infinity to positive infinity because we can land on one of these things. Now, your minimum value is going to be like, what, -2, and your maximum value is 4. So those are minimum and maximums. I think that's really all that you'll need to know about these. On this, it looks like the range would not be in interval. Okay, the way you would write the range is the little sideways mustache, and your options are, what, -2, +2, or 4. Okay, you wouldn't do the little brackets or parentheses. Okay, you're not going to do that with this one because for the range. All right, let me just get rid of all this. Let me move that out of the way so we can look at the other problem. All right, so the next one, you've got, if you graph this correctly, then you have a picture that looks like this. Notice how we don't have the gaps like this one. There's no gaps. They kind of connect, but there's still 3 very distinct parts to this. Just honestly, can you graph these in your calculator and find the correct graph? That's really all you need to do with the piecewise functions. Now let's look at this example. This is an application problem that's going to be very similar to one that you're going to see on your test. Okay, let's see. So you have the function f of x equals 3.6 times x, and it gives the cost in dollars of buying x gallons of gas. The function g of x equals 30 times x gives the distance in miles Chris can drive his car in x gallons of gas. Chris wants to go to Paris, France, 900 miles away. How much money would he need to make a round trip to Paris? Okay, so a couple things you need to know is we're looking for how much money he needs, but you have to find out other things before you find out how much money he needs. And mainly you need to find out how much it costs to drive 1 mile. Okay, you want to know what are the costs, okay? To do that, it may not be readily apparent on here. But if it costs $3.60 for 1 gallon of gas, and you can get 30 miles on a gallon of gas, then you're going to take the $3.60 divided by 30, okay? If you want to know the money per 1 mile, then you set up the equation like this, $3.60 divided by the 30 miles. So essentially what you're doing is you're taking the F equation and dividing it by the G equation. Okay, when you do that, you get 12 cents. So it'll cost 12 cents to drive 1 mile. So how many miles does Chris need to go? Well, he's going to Paris, France, which is 900 miles away, but he wants to make a round trip. Okay, you don't want to just get there and then not be able to get home. So the distance that they're traveling is going to be 1,800 miles. You'll take the 1,800, multiply it by your price per mile, 12 cents, and you stick that in the calculator if you can't do it in your head. Honestly, I can't do it in my head. So I'll use my calculator, and it just gives me $216. Okay? You will have a problem just like this. This value might change, this value might change, this value might change, but all the words are going to be completely the same. Okay, so make sure you know how to do this. You might want to jot down notes on your index card for this problem. All right, you will have a problem where you have to describe the end behavior of the function. It tells you without first graphing the equation. Honestly, I don't care if you graph it or not, as long as you can tell me what all this means. Okay, and so pay attention to which side of the graph you're looking at. For this one, because our A is negative, the right side is going to go down. And because we have an odd function here, odd power there, the left side is going to go the opposite direction of the right. So the right side is going to go down and the left side is going to go up for number 26. If you look at all these, they all look very similar. The one, let's see, I think this is the one we want. As x approaches positive infinity, so the right side is going to, y is going to approach negative infinity. So this part tells me that the right side is going down. And as x approaches negative infinity, so the left side, your y is approaching positive infinity. So this one tells me that the right side is going down, the left side is going up. And that is exactly the scenario we have for 26. Now let's look at 27. Again, I have a negative a value, so my right side is going to go down. Because my exponent is an even number, my left side is going to do the exact same thing that my right side does. So both of my graphs are going to be, both sides of my graph are going to be pointed down. So I need to find the one where I have two negative infinities for my y's, and that's the one right here. So this problem, or this end behavior, describes 27. All right, and then 28, my a value is positive, so my right side is going up. My exponent, or my power, is a positive, or even number, excuse me. And so my left side is going to do the same thing that my right side is going to do. So I need positive infinity and positive infinity. There we go. So this one goes to 28, which leaves this last option to 29. And just to check, my A is a positive number, so my right side is going up, and my exponent is in odd degree, so my directions are going to be in opposite directions. So let's see, the right side is going up and the left side is going down, so that one's 29. All right, these are the only 4 options that or possible outcomes that you can have with end behavior. Actually, I just misspoke. Sometimes your graphs will they might approach a asymptote. For instance, if you had a graph that looked like this, you would say on the right side, y is approaching 0. Okay, that's another example or possible end behavior. All right, let's look at the next set of examples. State whether or not each function is a power function, then explain your reasoning. So first, let's look at what a power function looks like, or what the correct format for a power function is. You have y equals some number a times x raised to the b power. So that's the format that we want. You guys should be very familiar of this. This is straight out of your homework. So let's look at the first one. That one is a power function and it's in the correct form. Remember, if it's not in the power function format, but it is a power function, I want you to go ahead and convert it to a power function. 21 is not a power function. We can't combine those two terms to one term like this. And then 23 is a power function. Yes, it is. But it's not in the correct format. To get in the correct format, you would set it up like this. Okay, so you need to be able to tell which one is a power function, and if it's not in the correct format, how to convert it to the correct format. All right, so 20, let's see, I think yes, it is a power function, and the correct format would be like this. Don't forget, if your x is in the denominator, the power would be x raised to the -1 power. Let's see, this is a power function and it is in the correct format. This is not a power function, this is a exponential function. So make sure your x value is in the base number, not the exponent in this case, because my variables in the exponent, I do not have a power function. All right, lots of graphs with this one. You have this scenario, it's straight out of your book. I will, on every single test, I change these values a little bit, so you can't just find the formula in the textbook and then just copy the formula down, okay? This is right out of one of the problems in your textbook. First, you need to find the power regression, and then with that formula, you need to calculate something. So just real quickly, when you're setting up your spreadsheets, make sure you put a title on your column headings. Okay, really quickly, let me show you where the spreadsheet is. Okay, to pull up the spreadsheet, there's 2 ways you can get to it. You can do new documents and then list in spreadsheets, or if you're on the home screen, you can just click on that button right there and it'll pull up your spreadsheet. Okay, either method will work. All right, so here's my spreadsheet. Make sure you label your column headings. Do not put anything in here because it messes everything up. And when you are done, make sure, I think I don't have a picture of the 7, but it's okay. Make sure your columns have the same number of cells that have information in them. Like, for instance, if you had in this column, if you had like -2 or something, but this was left blank, any type of regression you tried to get would come out an error message because the columns aren't equal. All right, so once you set up your spreadsheet, you're going to do a power regression. To do that, you're going to go to Menu, then Statistics, Stat Calculations, and then power regressions is just one of the options. Okay, once you do that, once you select power regression, you have to tell the spreadsheet, or you have to tell the calculator which of the variables or columns is your x value. In this case, we have the time it takes for a ball to hit the ground, or the distance the ball is falling, and how long it is. So in this case, your x is your time value, your y is your distance, and just use your little drop-down menus here. Then push OK. Once you push OK, you'll get your power regression. And then the equation is right here. Here's your A value, here's your B value. And some of my students are like, well, I don't know how to put it in the equation. Well, this box right here tells you how to set it up. So the formula, you would write it as 5.13 times x, and then whatever your B value is, in this case 2.0098 would be your exponent. Okay, that's all you have to do to set up the formula. Let me see, I think that was the last one on that one. Yep. Okay, and then so now we have our power regression. We have this equation. The next question, after you have the equation, you have to use the equation, determine how many seconds it takes for the ball to hit the ground if the students drop the ball from 10 meters up. Okay? There are shortcuts to this. You don't have to do all the calculating if you don't want to. I mean, obviously you can. An easy thing to do, though, you can just add a graph. To do that, you do Control Documents, and then this screen will pop up. Do add a graph. Once you've added the graph, you can scroll up and you'll see your power regression up there. Just push enter. You will want to, when you do that, you get this page, but you will want to change your windows. Come on, get out of the way. Sorry. All right, to change the window, go to Menu, Window, Settings. Option 1 is Edit Window Settings. Because we want to know how long it takes the ball to drop if it's from 10 meters up, you want your Y maximum to be more than 10. Okay, in this case we did 15. Okay, once you get that, your window set up, then, let's see, this is the one I want next. Yeah. Then in F2 of x, you're going to say F2 of x equals 10 and push enter. When you do that, no, that's not what I want. That's one. You get this line. And now all you have to do is find the intersecting point right here. Okay? And then to find the intersecting point, let's see. I know I go through a lot of these basic steps. Most of you already know this. To do that, you want to analyze your graph. So you go to Menu, Analyze Graph, Find Intersection. And then you'll get a screen that looks like this, where it says Lower Bound. You need to have this dotted line on the left side of the intersecting point. Notice on my picture, I'm not having it like right up here. It just needs to be somewhere on the left side. It doesn't matter exactly where. Once you get it to the left side, you push enter. Then it'll say upper bound, and you need to move the dotted line to the right side. Notice I'm way over here. I don't have to be right next to it. And the cool thing is you don't even have to push enter for the calculator to automatically give you the answer right there. Okay, if you do push enter, then this little button or word moves out of the way, and you just get 1.37. Okay. Alrighty. Moving on. Okay, this one is like, there's 4 questions that all have to do with the exact same problem. So you have Yvonne earns $9 an hour for the first 40 hours she works in a week. She earns $13.50 per hour after that. Each week she deposits 15% of her earnings to her college savings account. Okay, so the 4 different things you're going to need to do with this information here. First, you need to create a function that can be used to determine Yvonne's earnings when she works X hours a week. Then we need to determine the amount Yvonne's going to deposit into her savings account. And then we're going to create a composite function of these 2 equations. And then we're going to use the composite function to figure out how much she will put into savings if she works 72 hours. Okay, now this is under the assumption that Yvonne is going to work more than 40 hours in a week. All right, so let's take this step by step. If we just wanted a function to determine how much she's making if she works X hours a week, we are going to have this equation. Okay? No, I don't want to undo. There we go. All right, so she's making $99 for the first 40 hours. So you have 9 times 40. And then it's overtime, so 13.5 or 1350 times X, the number of hours she works, minus 40. The reason why you have to subtract the 40 is because she's only getting paid $13.50 on the amount of time over 40 hours that she's working. Okay, so that's how you're going to initially set up the equation. Simplify as much as you possibly can. When you simplify it, 9 times 40 gives you 360. And then 1350 times x minus 1350 times negative 4 gives you negative 540, excuse me. You can combine like terms by adding these two terms together. When you do that, you finally get your f of x equation, which is going to look something like that. Okay. Again, you will have a problem on your test very similar to this. This number is probably going to change. That number will stay the same. This number might change, and your percentage might change as well. Okay, so that's how to find f of x. Now let's find g of x. G of x is just how much she deposits in her savings account. She's going to deposit 15% of her paycheck. So that's a super easy equation. It's just g of x equals 0.15 times x, however much she earns, times 15%. Easy? Easy. All right. The next step is to take your f of x and your g of x and create a composite function g of f of x. Okay? When you first set it up, it's going to look like this. Let me get rid of this big monster. Okay? So you're taking your d of x, you're taking your f of x, putting it inside your g of x. So you get this. You can go ahead and distribute that to simplify it, and your final function would look something like that. Okay? So the last question that has to do with this, now that you have your composite function, you want to know how much will Yvonne deposit into her savings account if she works 72 hours. Okay, so 72 hours is going to be plugged in to this equation for x. Okay, oops. When you do it, you just plug it into your calculator just like that. And when you calculate everything out, it looks like Yvonne's going to deposit $118.80. That's actually a pretty good amount for a savings account. All right, next one. Based on the table below, what is the inverse of f of 10? Be very careful with this function. On your scratch paper, set up a table for yourself. Okay, if this is f of x, then for the inverse of x, you're switching all your values. So all these x values here are going to become your y values down here. All these y values become your x values. Now, if you want to know what is the inverse of f of 10, you're going to use this table. This would be your x value. Okay. So when x is 10, what is your y value? Okay. From this table, when x is 10, here's your 10x, your y would equal 5. Okay. And that's the answer you would get. Notice if you use this table and you find x is 10, what's your y value? Your y value will be 20. Okay? That's going to be the wrong answer. The correct answer would be here. Okay? Everybody's going to have a problem like this. And notice how there's several of these where if you're not setting it up correctly, if you don't set up your inverse table, then you could easily get the wrong answer. Okay? Because you'll find some values here and here at the same time. Alright, so just be careful, set up your inverse table, switch the values and all that fun stuff. Alright, we are almost done with this. I know the video is pretty long. Everyone's going to have at least, yeah, I think it's just one function. One problem on the test where you are given an equation and you have to find the inverse of that function. Okay, there's several steps to it. The first step, doesn't matter what the equation is, first step is switching out the x's and the y's. Wherever x is over here, you put a y, and then you put the x over here. Second step is start solving for y. We want to get y by itself. So the first thing that we did is we took x and we subtracted by 4 to get rid of this 4. Then to get rid of the 2, we're going to divide by 2. Divide everything by 2. Okay, when you do that, you get x minus 4 divided by 2 gives you x squared. To get rid of, or the opposite of squaring something is taking the square root. So the final answer will be y equals the square root of x minus 4 divided by 2. Okay, that's just one possible formula you might have. Let's look at another one. The cube root of 3 of x minus 6. We're doing inverses, so again, switch your x and the y locations. Okay, now we need to solve. The opposite of a cube root is cubing something, so we're going to do x to the third power equals y minus 6, and then plus 6 to get rid of to move the 6 over. Easy, right? As long as you remember what the opposites of all these weird things are, then this is an easy problem. All right, here's another possible formula that you might have. X plus 1 to the fourth power minus 1. Again, switch your x's and your y's. Then start solving for y. Get y by itself. So we add the 1 over here. Then we're going to do the fourth root. And then we're going to subtract by 1. And that's what your inverse function will be. I think that's the last question. Yep.